Guys, so now we have our keynote speaker, Michael Dunn. He's going to present the infinite compute layer for Web3. Let's give him a welcome.
Hi everyone, this is Michael. I'm a co-founder and CEO of Brevis. And what we're building at Brevis is what we call the infinite computing layer for Web3. And before I dive into what exactly do we do, I just want to give you a quick introduction of why we're doing this. So blockchains are basically often marketed as world computers. But if you look at them very closely, they are very slow computers and often cannot run faster than a single server and extremely expensive. So you may think, okay, this is not the case because we have made so many progress over the last couple of years in blockchain, and we should be able to do any kind of computation on blockchain, right? Well, that is not actually the case. So let me give a very simple example here. So if you ever used centralized exchanges, you all have experienced this kind of the same feature where if you traded a lot in this month, you get a trading fee discount in the next month. But if you look at any decentralized exchange today, until very recently, you don't have this kind of a feature available. Now, why is that? The reason is that if you want to build this kind of feature in your smart contract directly, it will bankrupt you in gas fee. And the fundamental reason for this is that blockchains are actually built in the simplest form of computation possible, which is like a repeated computation. So let's say you have a blockchain with two nodes. And what they're trying to do here, essentially in any blockchain, is to try to achieve a consensus among different nodes in the system. So for example, Alice is now trying to compute what is the result of this multiplication equation. She spends some time in doing this and gets the result. So the next thing she needs to do is to convince that Bob, hey Bob, this is actually the result of the computation. So what Bob can do here is that before all, Brevis, there's only one way Bob can do this is to redo the computation again. So, Bob spent the same amount of computation power and then, get the same result. So in the current form of blockchain, what you can do here is that recomputation is the only way to do verification. And now, the reason this is a fundamentally, limiting for blockchain is because you don't have just two nodes in blockchain. You have millions of nodes in blockchain. And then, what happens here is that, the same piece of a computation gets repeated millions of times, and this is why fundamentally blockchains are slow and expensive. How to solve this? Well, we're solving this with a new form of computing called verifiable computing. In verifiable computing, you have different roles in the system. One is called a prover, in this case, Alice. And so Alice is not just doing the computation itself, but also generates something called a zero-knowledge proof. So this zero-knowledge proof is a very magical thing that she can use to send to anyone that the other party, which is now Bob, can easily verify that the computation result is done correctly. The nice thing about ZK proof is that you can verify the computation with extremely tiny computation cost. Now, the important thing to note here is that no matter how complex the original computation is, you can always verify the ZK proof with a fixed and constant cost. So there's also additional benefit on privacy because you can actually hide the input of the computation at the same time proving that you know some input that can arrive at a certain computation result. So next. Keep going. So why is this important? Well, this is important because this is what powers Brevis. The verifiable computing is what Brevis is built on, and this really enables blockchain application to achieve infinite amount of scalability with Web2-like user experience, and also have very much applicability in Web2 and AI world as well. So in blockchain specifically, how do you use Brevis? Is by augmenting it with your blockchain application. So now, your blockchain application, when it encounters some very complex and data-heavy computation, it doesn't need to run all these computations in the smart contract directly. It can offload the computation away from blockchain to Brevis. And Brevis is not only just doing the computation, but also generate a ZK proof. And the proof will be bridged back to the blockchain, where the smart contract can verify the computation easily and securely. So blockchain now become a glue point of your application instead of the kind of the central point of all computation. So Brevis is not theoretical. Brevis is actually now used by a lot of different top projects in the space, including MetaMask, Linea, PancakeSwap, Uniswap, BC, OpenEden, Euro, you name it. Like we actually kind of touch almost every sector in the DeFi space and also in the chain growth space. So what do we do with that? Well, there are various different kind of application use cases. One is reward distribution. The other is like new kind of intelligent DeFi features, and then even new kind of DeFi primitives that I can introduce more about. So, for example, we recently launched with Linea something called Linea Ignition that powers their 1 billion Linea token distribution. The reason that Linea uses us is that they now can allow users to generate a ZK proof to show that they have deposited their fund into various different kind of Linea ecosystem protocols and get reward directly. So this is like a new way to distribute and grow your chain in a fully secure, decentralized, and transparent way. So we also work with MetaMask on similar program to help them to grow their user while retaining full trust-freeness in the system. And so another category that we are pretty proud of is like what we call intelligent DeFi. So this comes back to the example that I mentioned. You don't even have VIP trader program indexes. Now you do. So we actually work with the PancakeSwap to launch this protocol, this program called Pancake Infinity, and this allows you to generate a zero-knowledge proof showing that you're a big trader, or you're a cake token holder or BNB token holder, and get dynamic fee discount based on your holding value, based on your trading volume that you've done in the past in the exchange. So this is again very powerful, bring personalized, customized user experiences to the DEX. So similarly on the stable token space, we helped to launch a lot of different stable tokens into the world, including Euro Money and also OpenEden. The idea is similar to the reward distribution use case, where you want users to use your stable token in various different venues, and you want to build a fully trust-free and kind of a fully trust-free reward system that is powered by ZK proof. Keep going. So yeah, for all these different use cases, we are already have, our ecosystem have more than, now 150K users, and we have helped all these protocols distribute more than $200 million reward and help them to grow $4 billion TVL. So all these examples that I mentioned before are kind of a half on-chain, half off-chain. And so the important thing I want to note is that we are actually seeing a lot of different applications that are having most of their application logic now off-chain. So we're working with a top perpetual DEX partner in the world to launch a new type of perpetual DEX that has the same kind of experience with a centralized exchange, but also have the benefit of the truly decentralized and also security with the same level of security like a layer 1 blockchain, but at the same time you also get some additional privacy benefits because now you can have something like dark pool orders. This will really help a lot of traders because they kind of now can finally avoid this liquidity assassination problem that is quite prevailing in the perpetual swap today. So my prediction is that in 10 years, 99% of computation for any blockchain applications are going to happen in an off-chain environment and in a verifiable way, and hopefully in ZK powered by Brevis. So what is actually inside Brevis? So in the center, what we have is something called a Pico ZK VM, and Pico ZK VM is a general purpose zero-knowledge proof virtual machine that is based on RISC-V instruction set. The benefit is that it is extremely developer-friendly, because it is general purpose ZK VM, you don't need to know anything about ZK. You can just write your program in high-level languages such as Rust. So we have a complete Rust toolchain that you can use to prove any kind of execution on your software. So Pico is also extremely performant. We are the world's fastest ZK VM with a single GPU setup. And we're getting faster every day. So like we are actually able to prove Ethereum's full block execution. This is something called a ETH proof that benchmarks across different ZK VM. We're actually the fastest one on there. And we're having something very exciting, announcing soon called Pico Prism that allows you to prove a vast majority of Ethereum blocks in real time. Now the reason this is important is because we can finally have 100 times or even 1,000 times scalability in blockchains such as Ethereum while maintaining the same level of trust assumptions, with maintaining the same level of decentralization and security like it is today. So this is very, very important, and not a lot of people talk about this, but you're gonna see and feel the effect of this in the next year. So Pico is fast, but it's not fast enough. Because in any kind of engineering domain, we always have this kind of a generality with performance trade-off, right? So what Pico is operating at that point, which is very general, but have some kind of performance limitations. So we know that for ZK, specialized circuit give you maximal performance while you don't have a lot of programmability. So where do we want to operate for Brevis as a whole project and a whole technical stack is there, like the best of the two worlds. Now, how do we achieve that? Well, we achieve that by introducing modularity in the entire technology stack and especially Pico design. So the idea here is that for Pico, we treat the VM itself as a glue. And it is so modular that you can plug in different specialized coprocessors into this glue for commonly used application patterns. So, one type of coprocessor I want to mention is something called on-chain data coprocessor. Right? So all the kind of use cases that I just mentioned have some relationship with the on-chain data. Right? So you're trying to understand whether a user made a certain deposit, did certain swaps in the past. So they are all kind of requiring the entire proving stack to prove whether user did such an action or not, and then run some computation on top, right? So so this is like a entirely kind of different system that plugs into our ZK VM that can help you to largely accelerate the computation for these kind of commonly used application patterns. At the same time, also reduce the cost in a significant way. So there are so many different other coprocessors. So we also notably have a ZK-TLS coprocessor that allows you to bridge off-chain information into the ZK world and finally in on-chain world. So you can basically prove to your DAXs in the future that you are a Binance user with more than $1 million in your Binance account in the last 30 days. So these kind of things become possible that now we can bridge many of the information that were not available on-chain to the on-chain world with this kind of a co-processing capability. So the reason you saw earlier that we have so many different partners like PancakeSwap, Linia, and all these is because we have this kind of a design pattern or architecture where for different kind of application use cases, we can simply build and add or integrate a new type of coprocessors and to serve their need. And this is why Brevis got the highest amount of adoption in the ZK kind of application domain comparing to other solutions on the market. So, of course, we want to make sure that the entire proving stack is decentralized enough and secure and live. Right, so this is why we're also introducing Brevis overnight to make sure that this entire proving process can happen in a perpetual kind of also the most cost-efficient way. So super excited about this upcoming launch for our Provernet, and hope you guys can follow us on that. So last slides. So that's fine. But yeah, well, to sum up, we built Brevis, which is a smart, verifiable computing platform that allows you to build new kind of applications by tapping into computational resources that were not possible before. And hopefully we can build some exciting applications together. Thank you.